So hello class and welcome again, and let's proceed for the part 4 of the curvilinear motion, which is your normal and tangential components. So it's another way of describing your motion in curvilinear manner. So again, this under the curvilinear motion, so normal and tangential components. So what are these? So what when the path along which particle travels is known, yan, kung known daw yung particle or yung path ng particle natin, then it is often convenient to describe the motion using n and t coordinates axes, which act normal to the tangent or normal and tangent to the path respectively. Ayan. So, it is another way of describing, no, the path of our particle. And it is said that if our path is the path of the particle traveled, no, the particle traveled, kung known yung path niya, then we can use this normal and tangential components where your n and t coordinate axis. And ito yung n and t coordinate natin. And then our origin is at the particle directly. Okay? So you have your origin prime, or that we're going to discuss that later in this topic. So in planar motion, so consider the particle which moves in a plane along fixed curve such that at a given instant it is at position S. Ayan. So measured from point O. Ito. Okay? This is your distance or your position S. And this is your unit vector of your N or normal axis, and then the tangent axis. Okay? So t-axis is tangent to the curve at the point, and is positive in the direction of increasing s. So the direction or the positive direction of our tangent na axis is along with the direction of the path or the s, or the move of the path of the particle movement. Okay? We will designate this positive direction with the unit vector u sub t that is moving along the direction where s is increasing. Ayan. So our unit vector sa direction natin sa tangent axis is, again, we assume that the positive direction of our tangent axis is along with the increasing path of the S, or the curve S. Okay? So the normal axis N is always perpendicular to tangential X or axis T. No, always perpendicular siya sa ating tangent axis or tangential axis T. So that's your normal axis. So note that geometrically that curve is constructed from a series of differential arc segments ds. Ayan. Kumbaga, ang thought dito is that each segment of our curve is defined or is constructed into smaller parts called ds, or smaller differential or small arc segments or differential segments, which is ds. Isipin nyo na lang na zoom into sa path ng curve natin, and then nakikita natin na may mga ds talaga. It is composed of ds na mga arc segment. So therefore, each segment ds is formed from the arc of an associated circle having a radius of curvature rho and center of curvature O prime. Ayan. So, ang each segments daw, it is associated with the radius of the curvature. Kumbaga, each curve may mga associate na mga origin, no? Each segment or arc segment, meron siyang corresponding na origin, which is O prime, no? Each of it. And then it is calculated by, again, that angle times the rho, or the radius of that arc away from that origin O prime. Okay. So the normal axis N is perpendicular to the t-axis with its positive sense directed toward the center of the curvature O prime. Now for the, again, we already said that tangential ko, no, ang positive daw na sense ng tangential is along with the increasing path of our S, no? Sa normal axis naman, yung positive sense naman niya is directed toward the origin of the arc segment. So, always, as you can see, concave to. Kung pa concave yung direction niya, yan yung positive sense ng normal axis natin or N na axis natin. Okay? This positive direction which is always on the concave side, no? As I have said, concave side ng curve will be designated by the unit vector u sub n. Now, for our tangential naman, u sub t. Now, for our normal is u sub n. Okay? Again, yung positive side ng uh, normal axis natin is nasa concave side ng curve natin. So always the concave. Again, as you can see here in the figure, yung concave niya is paganto, pa up, nasa upper, and then sa next curve naman natin is nasa lower. Always nasa concave, yung positive sense ng ano natin, normal axis. Okay, for the velocity, ano yung velocity, ano yung definition ng velocity kung gagamit tayo ng normal and tangential components. Since the particle moves s is a function of time, ayan, as indicated in lesson 3.2 or yung rectangular components ng ano natin, ng velocity, the particle's velocity v has a direction that is always tangent to the path and magnitude that is determined by taking the time derivative or first time derivative of the path function s of t, no? Hence, v is equals to v times u sub t. Again, bakit ganito? Kung ginamit pa natin yung rectangular component, may ang ano nandito is v sub x times I, di ba? So, in terms naman sa normal axis, dalawang lang yung component niya, which is the normal and tangential. Na for your velocity, and solving for your velocity vector it can be equal to velocity or the magnitude of the velocity at the tangential component or the unit vector at the tangential component of the particle. Again, dalawang component ang kinoconsider natin dito sa particle, yung tangential and your normal. Now, for your velocity naman, since it says here that always tangent, if we say tangent, of course, obviously, nasa tangential component siya. Di ba? So, V times U sub T. So, that's for your tangential component. Yung V. Okay? So, that's how you solve for the velocity involving or using normal and tangential components. Okay? Where V is equals to dot notation of particle's position or dot s dot or dot s or the first time derivative of the path or first time derivative of the function is equals to ds over dt. Okay? Yung value ng v dito is ds over dt. Okay? So the acceleration naman, so if the particle is the time rate of change of the velocity, no? Thus, a is equals to v or that notation of velocity is equals to the derivative of v times u sub t. Diba? We already know that kanina. So, in solving for the v, we just have to v times v sub t. So, acceleration, we define that the acceleration is the time rate of change or the derivative of the velocity. Therefore, we just have to differentiate this also. And this 2 is different variable on each other. No? So, in differential calculus, we again use product rule. So, that will become dv. Yan. So, the derivative of the first variable, dv, copy yung second variable, plus, copy yung first variable times the derivative of the second variable. So, eto na yung, kumbaga, to solve your acceleration using normal and tangential components, we have dv times u sub t plus v times du sub t. So, therefore, that v or the first derivative, since dv to, so first time derivative of the velocity times the u sub t plus v, the velocity times u dot sub t, no? Kasi nga, the derivative of u sub t, so may dot na siya dito, dot notation na siya. So, first time derivative of u sub t. Okay. So, to determine the time derivative, note that as the particle moves along the arc ds, ayan, as the particle moves daw along the arc ds, etong ds natin na, and time dt and u sub t preserve its magnitude of unity. Now what we call the magnitude of unity, u sub t is equals to 1. So equals to 1 daw siya. So however, its direction changes and becomes u prime sub t. Ayan. So since equal lang naman yung what they call this? Yung raw ng tangential or the next position. Again, initial position na to. So ni-change daw ng velocity, nag-change yung velocity natin or your position of the velocity. Therefore, mag-change yung direction ng tangential components ng final position or the position or the new position of the particle. Siyempre, mag-change yung direction natin dyan sa u prime sub t. Therefore, ang u prime sub t natin is na-create after moving the particle at another position. Okay. So, as shown in the figure, we require, ayan, u sub n. Ito, pa ganito. And then, always perpendicular again sa tangential component. And then, our du sub t, it means that the change of the tangential component, du. Again, we are trying to get the value of our du sub t or the first time derivative of our u sub t. We're trying to get this one, okay? So, as shown in the figure, we require u prime sub t is equals to u sub t, ayan, plus du sub t, 'di ba? Change of the change of u sub t, no? So therefore, du sub t stretches between the arrowheads of ut and then u prime sub t, which lie on an infinitesimal arc of radius ut. U sub t is equals to 1. Hence, du sub t has a magnitude of du sub t is equals to u sub t d theta is equals to 1 d theta. Therefore, kasi sinabi natin dito na nag-lie yung, what do you call this, ang arrowheads ng mga ut natin, u sub t, and then the u prime sub t sa infinitesimal arc of radius u sub t is equals to 1. Therefore, to find for the d sub t, this, diba? It is, uh, to solve for this is the arc length, diba? So, to solve for the arc length, you just have to multiply the radius and the angle of that change. So therefore, to solve for that, d theta, no? To solve for this du sub t, you can multiply the, ayan, ut times d theta. Diba? And then we said that u sub t is the infinitesimal arc of radius, which is equal to 1. Therefore, 1 times d theta na lang siya. Okay? And its direction defined by u sub n. Now, dito na nag-exist yung u sub n natin. Kasi yung direction niya ng du sub t is defined by u sub n. As you can see, pag ganun siya. Same, parallel with the direction of the u sub n. Ayan, o. Pag ganun din, pag ganun. Okay, what will happen next? So, u sub t is equals to theta times u sub n. Ayan. Kumbaga, yung first time derivative of the u sub t, it will be equal now to theta, ayan, theta u sub n. So, consequently, du sub t is equals to d theta times u sub n, and therefore, the time derivative becomes ganito. Okay? So, don't be confused. Du sub t and first time or that notation of u sub t is equal lang. Pareha, same lang sila in sense. And then d theta, we can just rewrite that at that notation since it's the first time derivative. So we can rewrite that that notation of theta times u sub n. Okay. Since ds is equals to rho d theta, ayan, another equation na naman. Since we defined this kanina, so ds equals to rho d theta as shown in the figure and using the arc length formula, then dot notation theta is equals to dot notation of s over rho. Okay, so we can now substitute the value of this one to this one. So therefore, u sub t now will be equal to theta, or first time derivative of theta times u sub n. Now, since the value of our first time derivative of theta will be equal to first time derivative of s over rho times u sub n. Okay? So therefore, u sub t pala, or your that first time derivative of u sub t pala is equals to v. Again, naging v siya kasi nga first time derivative of position is velocity. So we can just write that into v is equal u first time derivative of u sub t is equals to velocity over rho times u sub n. So, dito na yung nag-exist yung u sub n natin. So, u sub n, eto na. Naging ganito na siya. So, again, eto na yung pag-solve ng acceleration. Bakit naging v squared to? Kasi nga, kanina may v pa yun eh. So, kasi pag-solve ng acceleration natin is a is equals to the first time derivative of v times u sub t plus v, no? V times u sub tn, or first time derivative of u sub t, no? And then we already know, or we solved that the derivative of u sub t is equals to v over rho times u sub n. Therefore, v times v is v squared over rho times u sub n. So where your a sub t is equals to first time derivative is equals to dv over dt, or atds is equals to v dv, and then your a sub n is equals to v squared over rho. Again, note that the dot above a certain variable represents the first time derivative. Okay? Again, ang dot na may dot sa ibabaw ng variable mo, it means that it is the first time derivative of that variable. Okay? So, ang a sub t natin pala is can be calculated, or the norm or the tangential component of our acceleration can be calculated using that variable v, or equals to dv over dt. Now, for the normal component naman for our acceleration, we can solve for that for is equals to v squared over rho. Take note ha, yung dalawang to yung mga component natin, so that we can solve for the magnitude of acceleration using the vector sum of these components. Okay? Again, to solve for the tangential components of acceleration, dv over dt. Now, for the normal components naman sa acceleration, v squared over rho. Okay. Thus, a is equals to at times ut plus an times u sub n. A sub n, and a sub t are mutually perpendicular to components as shown in the figure. Ayan, a sub n. Take note, ito yung acceleration natin. And then, ang component sa acceleration natin is ang normal component of acceleration, which is defined by a sub n. And then, the tangential component of our acceleration is defined by a sub t. Okay, therefore, the magnitude of the acceleration is the positive value of the vector sum, of the resultant sum of the two components, which is a is equals to square root of 80 squared plus a sub n squared. So that's how you solve for the magnitude of the acceleration. So to better understand the derived formulas, consider the following two special cases of motion. Again, if the particle moves along the straight line, then rho becomes or approaches to infinite. So equation 3.4.4 will now become 0. So baga, wala na siyang normal. Wala na siyang normal component ng acceleration. Therefore, ang natira na lang is your tangential component. So, thus, A is equals to A sub t is equals to dv over dt. Kaya, kumbaga sa rectilinear motion or straight line path, hindi na-mention doon kung meron ba siyang normal component or wala. So, sa curvilinear, since hindi siya straight line, nag exist yung normal component ng acceleration or any other variable or motion parameter natin, no? May nag-exist yung a sub n natin since it doesn't move in a straight line. It moves in a um, curve nga curve na motion. So, nag-exist na yung a sub n natin. But sa rectilinear na manner, yung a sub n natin will be equal to zero since our rho will approach to infinite. So any variable, any constant, any ayan, divided by the by divided by infinite, it will approach to zero. Okay? So, ayun nga, A is equals to A sub t na lang is equals to dv over dt. Kumbaga, ang pag-compute na lang natin sa acceleration or the magnitude of acceleration in a straight line manner will be A sub t na lang. And then, we all know that the A sub t or the tangential component of our acceleration can be solved by dv over dt. Kaya yung formula natin doon sa rectilinear is we directly mention or we directly determine that by dv over dt since wala na siyang normal component sa particle moves along a straight line. Okay? So, and we can conclude that the tangential component of acceleration represents the time rate of change and the magnitude of the velocity. Yeah, we can now conclude that ang tangential components dahil sa acceleration ay yung tangential components pala ng acceleration, yan yung that's also the magnitude of the velocity. Kasi nga, uh, kumbaga, yung tangential components, we define that is equal to the dv over dt. And that's the time rate of change of the magnitude of the velocity. So, kumbaga, dito natin na-conclude na since wala tayong normal components and wala tayong normal components in a rectilinear path, so we can conclude that the tangential components pala or the tangential component of the acceleration pala ay yung time rate of change or dv over dt lang pala ng particle natin. So, can easily solve for the acceleration or for the acceleration. Okay? So, that second case naman. So, if the particle moves along a curve with a constant speed, ayan. So, second case to Yung first case is the particle moves in a straight line path. And the second case naman is the particle moves a curve with a constant speed. Then, at or the tangential component of the acceleration is zero. Kasi nga, constant speed, walang change of velocities, walang acceleration na nangyayari. But that's for tangential component. Kasi yan yung tangent or that's the tangent of the velocity. Yung movement ng velocity in a constant speed. But meron siyang a sub n. Kasi curve to eh. Kung if we say that it is in a rectilinear motion or a straight line path, we can say that our a sub t or tangential component of our acceleration will be equal to zero also. And then also with the a sub n, wala din siyang magnitude kasi nga it moves in a straight line path. But if the particle moves along a curve na siya with a constant speed, yung magiging zero doon is yung tangential component na. Ang a sub n naman meron ng value kasi nga v squared over rho. Okay? Meron siyang hindi siya na nag-respect sa path ng or direction ng velocity or ng particle mo kasi meron siyang sariling origin. When we say normal component of the acceleration, you can say that it has its own origin. So therefore, meron siyang distance or radius away from the um, origin, its own origin to the particle. So that's for your rho. That's the distance between them. And then if you square the velocity, that constant speed or the constant velocity, then you can have your a sub n. In that case lang ha, if your particle moves in a curve with a constant speed. If constant speed, yung a sub t yung naging zero, but not the normal component ng acceleration. Sa first case naman, is yung normal component ng acceleration naging zero since straight line path siya. Therefore, yung rho natin dito will will approach to infinity. And then any number divided by infinite equal to zero. Okay, walang value kumbaga. So, that's for the first case. Sa second case naman, it moves a curve. So, therefore, meron na siyang hindi a-approach yung row natin sa infinite kasi nag-curve na siya. Okay? Para siya na-move in a circle or yeah, meron na siyang radius. So, you'll have your normal components. So, therefore, the normal component of the acceleration represents the time rate of change and the direction of the velocity. Kumbaga, if ang tangent is concerned with the magnitude, ang normal naman is concerned with the direction. Take note ha, balik tayo sa first case. Sabi dito, we conclude that it is referring to the magnitude. Time rate of change in the magnitude of the velocity. That's for your tangential. It is concerned with the magnitude of the velocity. Okay? Okay, if again, if yung tangential is concerned with the magnitude, therefore, if constant yung speed or constant yung magnitude ng velocity, therefore yung tangential component would be equal to zero. But not the same as the case for the normal uh, acceleration. Kasi concerned yung normal component of the acceleration sa direction ng velocity. Kasi nga, if your particle moves in a straight line path, magiging zero siya. If your um, particle moves in a curve, in concern, it's in direction, hindi siya in straight line path. Therefore, meron siyang value. Meron siyang value. Kumbaga, yun lang yung mini-mean or kung ano yung idea ng normal and tangential component. Bakit kailangan pa to studyhan or bakit kailangan pa to uh, kailangan i-include, no? Kasi nga, yun nga, in curvilinear, nagiging dalawang component na yung just like this boy swinging in a park. Ayan, since hindi siya nag-move in a straight line path, since pag ganun yung natin, what they call this, parabolic or pa-concave upward yung movement ng bata. So, hindi siya in straight line path. Therefore, your there will be exist or there will exist na normal component ng acceleration tas tangential component ng acceleration. So, kumbaga, that's for the real life example na ma-apply mo yung normal and tangential components. Now, in some cases, just these two special cases, um, if the particle moves in a straight line path, yung magiging zero is your a sub n or the normal component. If the particle moves in a curve na siya, but constant yung speed, nagiging zero yung a sub t. Since the a sub s is concerned with the direction and a sub t concerned with the magnitude. Kumbaga, yun lang yung idea, no, sa normal and tangential components. Now, remember that the normal component of the acceleration always acts towards the center of the curvature or always on the concave side of the curve. This component is sometimes referred to as the centripetal or center-seeking acceleration. So, yun yan lang kumbaga yung another idea of the normal component. Another term for it is centripetal acceleration. Kasi, yeah, center seeking. Sarag, always, papasok sa concave or pasok sa movement ng ng particle mo. Always papasok siya sa pag-move ng mo. Kaya tinawag siyang centripetal acceleration for your normal component, ha? But hindi sa tangential. So, as a result of this interpretation, a particle moving along the curved path will have acceleration directed as shown in the figure below. So, in this first scenario, it says that increasing speed. Therefore, meron siyang normal and tangential component. So, next scenario is change in direction of the velocity. Ayan. So, pa-concave, always concave siya. So, doon yung positive, ano niya, what do you call this? Ang A sub t or tangential component says that its positive sense is the increasing sense of the speed, di ba? So, nasa itaas yung A sub t or tangential component kasi nandun yung sa taas yung pag-change or pag-increase ng speed. Okay? And we say that the positive sense of the acceleration component of tangential component of the acceleration is positive sense in increase yung speed. Now, in terms of the normal component of the acceleration, it says that it is positive sa concave na side. Okay? Ayan, so concave sa positive yung A sub dito. Sa next naman is change in direction of the velocity. Therefore, nasa itaas naman yung A sub n natin kasi andun yung concave again. And then, yung A sub t natin, since nag-increase siya sa baba, therefore, your A sub t is nasa ibaba din. Change in magnitude of velocity, dyan. So the third scenario naman, A is equals to A sub t since nag-move na siya in a straight line path. So, wala nang A sub n. Wala na siyang concave, wala na siyang curve, wala na siyang rho, and also, we can say that A is equals to A sub t na kung straight line path na siya. Wala na siyang normal component. Okay? So, that's for your normal and tangential components. So, summary. Coordinate system. If the path of the particle is known or provided, we can establish a set of n and t coordinates having a fixed origin, which is coincident with the particle at the instant considered. Okay, it says here na we can establish directly the n and t coordinates having the fixed origin, no? Which is coincident with the particle. Kumbaga, i-establish natin yung mga fixed origin natin for the nt coordinates sa mismong particle. Okay? Ganun lang, kumbaga yung idea dito. So the positive tangent axis acts in the direction of the motion, and the positive normal axis is directed toward the path center of the curvature. Alam nyo na yun. And then next is for the velocity. So the particle's velocity is always tangent to the particle's path. Ayan, we all know that one. The magnitude of the velocity is found from the time derivative of the path function. That is this one. And we all know that already. For the tangential acceleration naman, the tangential component of acceleration is the result of the time rate change of the magnitude or in the magnitude of the velocity. Again, magnitude of velocity ang binabasehan ng tangential acceleration. Okay? So this component acts in a positive s direction if the particle's speed is increasing and opposite naman kung decreasing. Okay? So the relationship or the relations between A sub t, v, t, and s are the same as for rectilinear motion. Namely like this. Same lang pa rin. Ganun lang talaga yung pag yung diniscuss natin sa rectilinear motion, tangential acceleration yung minimi natin doon or ginagamit natin doon. Kasi nga rectilinear, it's moving in straight line path, so walang normal component. Tangential acceleration lang yung nag-exist doon. Kasi nga, ang velocity doon is tangent, always tangent to the path. No? So, you can say tangential acceleration lang na nag-exist doon sa rectilinear motion that we have discussed on lesson 2. Okay? Alam nyo na yan. So, if A sub t is constant and A sub t is equals to A sub tc, we can use the equations from the rectilinear motion with the constant acceleration, which are eto. Kung constant yung A sub t natin or your constant yung tangential acceleration natin, we can compose or we can create, no? We can formulate these formulas using our integral or integral calculus to solve for the constant acceleration. Again, constant tangential acceleration. So we can create these formulas to solve for your rectilinear motion. Okay? So a normal acceleration naman is the result of the time rate of change in the direction. Direction naman yung concern sa normal acceleration as we learned. So this component is always directed toward the center of curvature of the particle's path that is along the positive in axis. Kumbaga, again, yung positive sense niya is toward the center of the curvature. Okay? And normal acceleration pa rin, the magnitude of this component is determined by, again, v squared over rho. Yan. If if the problem asks you to solve for the normal component of the acceleration, you just use this one. Okay? A7 is equals to v squared over rho. And if the given particle's path is expressed as y is equals to f of x, the radius of curvature at any point of the path is determined using the equation of this one. Simple lang siya, the class, nasa 1 plus dy over this dx. Kumbaga, after you differentiate the equation of the y, you just have to square it out. Then, add mo lang ng 1. Tapos, i-erase mo sa 3 halves. And then, divide mo lahat sa d squared y over dx squared. Simply, it's just the second time derivative of your y. Simple lang. Okay? Itong denominator mo is the positive value or the absolute value of the, what do you call this? Second time derivative. Okay? Take note, second time derivative of your y or your function x. Okay? Ano lang siya kasimple. So let's have an example para naman ma-apply natin yung mga learning kung meron man. So when the skier reaches point A along the parabolic path, as shown in the figure, he has a speed of 6 meters, which is increasing at 2 meters per second squared. Determine the direction of his velocity and the direction and the magnitude of his acceleration at this instant. So neglect the size of the skier in the calculation. So let's have our given. So given is the speed of 6 meters per second, the acceleration 2 meters per second squared, the function y 1 over 20x squared, and this figure. You have your initial position of your skier is at 5:10 or at 10:5 rather. Uh, xy coordinate ng skier niya is 10:5. Okay? So the required is the direction of the skier's velocity. Ano yung direction? Ano yung angle na direction sa skier? Okay, so determine the direction and magnitude also of his acceleration at this instant. So to solve that, determine the direction of skier's velocity. So let's have our coordinate system. So although the path has been expressed in terms of its x and y coordinates, you can still establish the origin of the nt axis at the fixed point A. Ayan. So, nilagyan natin ng axis ng n, tsaka uh, t. No? T. nt axis. Okay. So, determine the components of V and A along this axis shown in the figure. No? By the definition, the velocity is always directed tangent to the path since y is equals to 1 over 20x squared. dy over dx is 1 over 10x. Then at x is equals to 10 meters, your dy over dx will be equal to 1 since 1 times 10 over 10 is 1. Okay? Hence, at A, velocity makes an angle of theta is equals to arc tangent 1, which is equals to 45 degrees. Ayan. Diba? So, with x-axis shown in the figure. Ayan, dito. Therefore, the direction of their velocity is 45 degrees below the horizontal. Ganon lang kasimple. Kumbaga, since we are talking about velocity here, so we are going to take the first time derivative of the path or of the function of the path. No? Since the function of the path is defined by y is equals to 1 over 20 x squared, and then velocity yung uh, we are talking about right here. So, i-differentiate mo lang siya, and then after you differentiate, substitute the value of the x, which is 10. So you have your dy over dx, which is 1. So this is the slope actually of the path or of the function. So therefore, if this is the slope, you just have to arctan that, or use the arctangent or inverse tangent of that slope. So you'll have your theta, which is equals to 45 degrees with the x-axis shown in the figure. Ayan. So, if 45 dito, so, iyang adjacent, so kanyang adjacent sa x-axis, so that's your A, or direction of your velocity. Ito yung direction niya. So, 45, 45. Okay? So, that's how you solve for your direction of your velocity. So, determine the direction and the magnitude of the skiers acceleration at that instant. So, the acceleration is determined by this formula, di ba? So, using the normal and tangential components. So, we have the first time derivative, or a is equals to the first time derivative of the velocity times u sub t plus v squared over rho u sub n. However, it is first necessary to determine the radius of the curvature of the path at a 10 meter 5 meters. So since d squared y over d squared dx squared is equals to 1 over 10. Now this is the second time derivative of the function y is equals to 1 over 20x squared. So since our first time derivative is 1 over 10x, no? Kung i-differentiate pa natin yun further, it will result to 1 over 10. So this is the second time derivative, again class, second time derivative of the function of the path. Then, so solving for the rho, ayan, so we have 1 plus the derivative of the function, first time derivative of the function, squared quantity raised to 3 halves all over the second time derivative. Therefore, 1 plus 1 over 10x, since this is the first time derivative of the path, no? Squared mo yan, tapos quantity is 3 over squared all over 1 over 10 when x equals to 10 meters. So, substitute mo lang yung 10 meters sa x mo dito, so you'll have your rho, or your the radius of the curvature of 28.28 meters. So therefore, you can solve for your acceleration na. So therefore, the acceleration becomes a sub a, or acceleration at point A, will be equal now to 2, since our velocity or first time derivative of 2 when uh 'di ba kay 'di ba it is given na acceleration or increasing yung velocity niya at 2 meters per second squared, given to eh. That's your for tangential tangential, or the first time derivative of the velocity. Okay. So that's for your 2. This is given class ha sa problem. Tingnan natin ulit if this is given. Ayan. So increasing at 2 meters per second squared. So that's your acceleration and tangential component. So solving for that, it becomes 2 u sub t plus 6 meters per second squared mo yan, all over 28.28 sa nasolve natin na rho. Therefore, your final acceleration vector is 2 u sub t plus 1.273 u sub n meters per second squared. So, meron ka ng tangential component, which is 2, and then normal component, which is 1.273. Therefore, you can solve for the magnitude of your acceleration by using the resultant vector, which is the square root of the first tangential component, 2, squared plus 1.273 squared is equals to 2.37 meters per second. And for the direction of that acceleration is that the tangential component over the normal component, which is y over x. So that's for arc tangent of 2 over 1.273, which is equals to 57.5. So therefore, to solve for the direction of the acceleration, thus 45 degrees plus 90 degrees plus 57.5 degrees minus 180, that will be equal to 12.5. So that A is equals to 2.37 meters per second squared. This is your magnitude. And then for your direction is 12.5 degrees below the horizontal. Yeah. So that's how you solve for your um, acceleration, magnitude of the acceleration and direction using the normal and tangential components. Okay. By using anti-coordinates, we're able to really solve this problem through the use of ito. Kasi given itong tangential component na acceleration, tas we already solved the velocity and rho, so we can solve for the a sub n, and then ginamit na natin yung resultant vector na sum. So, since it accounts for the separate changes in the magnitude and direction of v. Ayan. So that's how you solve for the normal and tangential components. So let's have another example. So says here that a race car C travels around the horizontal circular track that a radius of 300 feet as shown in the figure. If the car increases its speed at a constant rate of 7 feet per second squared, starting from rest, determine the time needed for it to reach an acceleration of 8 feet per second squared. What is its speed at this instant? So we are to find the time to reach the acceleration of 8 feet per second squared and the speed or over the magnitude of the velocity itself. Okay, so the given r or the radius is equals to 300 feet. Our a sub t is 7 feet per second squared. Determine the time needed for a to reach an acceleration 8 feet per second squared. This is the required. So what is the speed at this instant? So determine natin kung ano yung time na kailangan to solve for the acceleration rates to set from 7 to 8 feet per second squared. So let's have the coordinate system. The origin of the n and t axis is coincident with the car at the instant considered. Ayan, always nasa particle talaga yung mga axis natin sa normal and tangential component. The t-axis is in the direction of motion. Ayan. And the positive axis is directed toward the center of the circle. Ayan. So we have our axis na. And this coordinate system is acted since the path is known. So the acceleration, the magnitude of the acceleration can be related to its component using, ayan, so a is equals to square root of 80 squared plus an squared. So here at 7 feet per second squared, that's for your tangential acceleration. Since a sub n is equals to v squared over rho, the velocity as a function of time must be determined first. So, kailangan pa natin i-identify kung ano yung function ng velocity natin with respect to time. Okay? So, for our normal tangent or normal component of our velocity. So, the magnitude, ayan, so v is equals to v sub o plus a sub t sub c plus times t. So, since ang initial velocity is 0 plus 70 since your acceleration is 7 meters per 7 feet per second squared and times t. Thus, our a sub n to compute for our normal component of our acceleration v squared over rho. Therefore, 7t squared, so this is your function of your velocity with respect to time, no? In terms of time, no? So 70 squared over 300. Since this is given, this is the radius of the curvature, which is the radius of the circle, which is 300. So we have 70 squared over 300, which is equals to 0.163 t squared feet per second squared. That's for your a sub n. So the time needed for the acceleration to reach 8 feet per second squared is therefore a is equals to square root of 8t squared plus a squared n. And then we already solved for our 8 feet. Oh no, this is given kasi ito yung kailangan natin na ma-reach, no, for the for the magnitude of our acceleration. And therefore we can use this formula to solve for our time needed. So square root of 7 feet per second squared. This is given for the tangential. This is the acceleration, no, given. Plus our solve na a sub n in terms of t so that we can solve for the time needed. Therefore, if you calculate that in your calculator, solving for the positive value of t yields to t is equals to 4.87 seconds. So this is the time needed para ma-reach niya yung 8 feet per second squared na acceleration. Okay. So that's how you solve for your time needed. So how about the speed at that instant? So when we say at that instant, we will going to use the speed. We are going to use the time that is solved kanina, that was solved kanina, which is 4.87 seconds. So v is equals to 70. We already solved that using the um, particles velocity. No, this is v final velocity is equals to v initial velocity times 80 squared. So 80 rather. So we have v is equals 70. So is equals to 7 times 487. Substitute mo lang yung t sa 70. So we have your 7 times 4.87 seconds. So therefore your velocity will be equal to 34.1 feet per second. Ito yung speed niya at 4.87 seconds sa pag-move ng race car. Okay. So note that remember that the velocity will always be tangent to the path, whereas the acceleration will be directed within the curvature of the path. Okay, remember class na velocity again is the tangent to the path, whereas yung acceleration will be directed to the curvature of the path. So I think that's all for the lesson 3, and I hope you learned something. And if you have concerns, questions, and clarifications, just message me or contact me directly. Okay? See you for the next lesson, where our lesson for the next topic or for the next lecture video will be now planar kinematics of rigid bodies. Okay? See you in the next video class, and have fun while learning.